In this discussion, we are going to talk about these trigonometric integrals. So we have actually two objectives here. The first one is to solve the trigonometric integrals involving power of sine and cosine. Now, what does that mean? It means that we are going to solve the integration of something like this. Right, integrate sine with the power and the cos with the power. Okay, so we are going to solve something like this. And the second objective is to solve the trigonometric integrals involving power of secant and tangent. So for the second objective, we are going to solve the integration involving the power of secant and the tangent of secant. So basically, right, this is what we are going to discuss under this topic. Okay, so as we mentioned earlier, right, we want to discuss how to solve the integration involving the power of sine and the power of cos, also the power of secant and the power of tangent. Now, to find the derivative of this form, we are going to break them into the combination of trigonometric integrals to which you can apply the power rule. Okay, so we are going to use the power rule to solve this. So what is the power rule? All right, the power rule refer to this one. Okay, so when we integrate x to the power of n, we will actually plus 1 to the power and then divided by the new power, new value of the power. So we are going to use the power rule to solve this one. So what we are going to do is we are going to break this, all right, into the combination of trigonometric integral. Okay, so now we are going to break this into the combination of trigonometric functions. So using these three formulas, the first formula is sine square x plus cos square x equals to 1. Okay, so this is the Pythagorean identity. So we are going to use this one, all right. Okay, also with another formula, sine square x is 1 minus cos 2x over 2, and cos square x is 1 plus cos 2x over 2. We are going to use these three formulas to help us, right, to break this into the combinations of trigonometric functions. Now, before we continue, all right, let's start with some revision first. Now, we know that if we differentiate, okay, if we differentiate sine to the power of 6, okay, x, okay, sine to the power of 6x, so we are going to use the chain rule to differentiate this one. So what we do is first we differentiate the function outside. So 6 we bring down, right, the power 6 bring down, we multiply, and the power reduced by 1, so 6 minus 1 we have 5, and then we have the x. Now after that we need to differentiate the function inside. What is the function inside? Sine is the function inside. Okay, suppose this is actually sine x to the power of 6. Okay, so the function inside is the sine. So we differentiate the function inside, we get cos x. So we multiply cos x. Okay, differentiate sine, we get the cos x. So we have 6 sine to the power of 5 x cos x. Now, since we differentiate sine to the power of 6 x, we get this. So we know that the integration is actually the reverse. Okay, the integration is actually the reverse of this. So when we integrate, this cos x will actually, after reverse, it will actually right, reverse back to the sine. So we do not have the cos x anymore, right? After the integration, right? Cos x, we actually get from sine. So after integration, it will actually reverse back to sine. So we only need to consider the sine here. Okay, so when we consider the sine here, right, we have, right, power plus 1. So we have 6, power 6 here. So divided by 6, simplified, we get sine power 6, right, to power 6 x. So we get back the original function here. Okay, so now what I want to highlight is this cos is actually the differentiation. So after the integration, it will actually go back. So we can also use the substitution method to solve this. Now let us use the substitution method to solve this one before we continue to explain, all right, the integration involve the power of sine and the power of cos. So we can use the substitution method to solve this integration as well. So first, all right, to integrate sine to the power of 5x cos x. So we let the u be sine x, right? Let the u be sine x, and then differentiate du dx. We will have cos x. Okay, so in this case, all right, the du now will be cos x dx. Okay, so that's one, cos x dx. Okay, cos x dx here. Now we can replace this one with du. So in this case, we can actually rewrite this as integration. Now the sine x is the u, so we replace this one with u and to the power of 5. So the cos x dx now replaced with du, right? Cos x dx is the du, right? So we have a du here. So we can actually integrate from here. So you can see here, right? So when we actually, right, replace the sine with u, right? We have u to the power of 5, and the cos x dx, right, replaced with du. So we have this. So integrate, we plus 1 to the power and divided by the new power plus c. So we have this one. Okay, so we can actually use the substitution method to integrate this. So next we are going to learn the integration involving the power of sine and the power of cos following these guidelines. Now first, right, when the power of the sine is odd and positive, so when this power is odd number and positive, now we are going to save one sine factor and convert the remaining factor to cosine. So it means that now this is odd number, so we are going to, okay, factorize one out, right? We have one sine here out. Now then this will be, okay, the remaining here will be 2k only, power 2k. So we are going to change this, all right, to sine square, all right, to the power of k. And after that, okay, we are going to change the sine square using the trigonometric identity. Change this one to 1 minus cos square x to the power of k. Okay, so however, before that, remember we are going to save one sine x. This one is for the du, all right, as we mentioned earlier here, all right, we want to save something here for the du. Okay, so if the sine is with the power odd number, so we are going to take out 1, okay, to save for the du. Okay, so these are the guidelines if the power of sine is odd. Now, if the power of cos is odd, right, we do the same thing. So we are going to take 1 cos here to save for the du. So you have 1 cos x here, all right, factorize out to save for the du. And now here remain the power of 2k. So we make it cos square x to the power of k, and after that change this cos square x to 1 minus sine x, right, of cos to the power of k. Okay, so by this we can actually reduce, all right, the function to sine only, and this cos x dx here, all right, we can actually change to du later. Okay, the same goes here. Okay, so we reduce the trigonometric function to the cos function only, and the sine x dx here, this will be the du later. Now, when the both power, okay, when the power of both sine and cos, they are even, means that, all right, both they are even power, with the even power, and they are non-negative. So we are going to repeatedly use the identity this one and the cos this one, right, to convert the integrand to odd power of the cosine. Okay, we are going to repeatedly use this one until we get the odd power, and then proceed in the second guideline. Okay, now let's see some example. Okay, now the first example, we have sine to the power of 3x, cos to the power of 4x. Now we can see here the power for the cos is even number, the power for the sine is odd number. So we are targeting the odd number, so then we are going to focus on the sine. So what do we do? Right, first thing, right, from here we are going to take out one sine. Okay, as you can see, we're going to take out one sine here. Right, this sine is reserved for the du later. Okay, so we are going to break it, all right, to sine square and sine x. Okay, sine square and sine x. So that's one, all right, we're going to reserve for du later. Now, after that, we are going to change this sine square x using the identity, all right, we have the identity sine square x plus cos square x is equals to 1. So from here, we can actually change the sine to sine square x to 1 minus cos square x. Okay, so replace the sine square x here with 1 minus cos square x. All right, so then after that, we can expand this. We have 1 times cos to the power of 4x minus, now cos square x multiplies cos 4x, we get cos to the power of 6x. Okay, sine x dx. Now after that, we can actually split this into 2. So by moving the sine x dx, right, split this into 2 inside here, we have integrate cos to the power of 4x sine x dx, and the other one is cos to the power of 6x sine x dx. Okay, so now as we mentioned earlier, by using, all right, the substitution method, this will be the du. Now, however, we know that, okay, when we differentiate cos, we get negative sign. Okay, so we need a negative sign here, right, to integrate. Okay, so therefore we create a negative here and a negative here. Okay, so we have negative sine x dx. This is actually the differentiate of cos, and all right, the negative is to balance up this one. And also, all right, so this is supposed to be a negative. So when we create a negative here, okay, when we multiply a negative here, so we are going to multiply a negative in front as well, and this make this become positive. Okay, and this will be the negative sine x. So finally, we can integrate this one. Okay, and we will have this. So if we are using the substitution method, so this means that we actually let the u be the cos x, and du dx is actually negative sine x, and the du will be negative sine x dx. Okay, by substitute, right, this into here, now we have a negative integration of u to the power of 4, and the negative sine x dx here, right, is this, which is du. So we are going to replace this with the du. Okay, replace this one with du. So we have a du here. And then after we integrate, we get, right, 4 plus 1, 5, and divided by 5. And we change the u back to cos. Okay, so this is the integration using the substitution method. Now, the same process, all right, we apply to the second integration here. Okay, so second integrand here, so we have plus. Now this will be u to the power of 6, and this one is actually du. So when we integrate, so we have 6 plus 1, 7, right, divided by 7. Change the u back to cos x, right, plus c. Okay, so this is actually how we actually break the function, right, from here. Okay, break into the cos and with the sign behind, right, save this one to be the du, and then we integrate. Now let's continue with the integrals involving powers of secant and tangent. Okay, when we have integration involving the power of secant and the power of tangent, so we are actually evaluating, all right, something like this. Right, so we follow the following guidelines. So if we have the power of secant is even and positive, so we are going to break this into, all right, secant square k minus 1 with the secant square here. Okay, so after that, right, for this secant square, we use the trigonometric identity. Now the trigonometric identity we have is 1 plus tangent square x equals to secant square x. So we are going to change the secant square x here, break it into 1 plus tangent square x, all right, with the power k minus 1 here. Okay, so we have tangent to the power of nx and the secant square x dx. Now, again, this secant square x dx, we are going to save it for du. Why? Because when we differentiate tangent, okay, we do a revision here. Now, differentiate tangent, what do we get? We get secant square x. Okay, so when we integrate secant square x, we are going to get back the tangent. Okay, so this one is to save for the du, so that when we integrate, when we change the tangent to u, so when we integrate, this will be the du. Okay. Now, the second guideline will be, now when the power of tangent is odd and positive, if this is odd, then we are going to break this into tangent square x to the power of k and tangent x. So we break this into 2. Okay, so means that we have tangent power 2k plus 1 x. Okay, we break it into tangent 2k x multiply tangent x. Okay, so now this tangent x dx later, all right, we are going to save this one with the secant x, right, secant x tangent x for du. Okay, now why we need to save this one for du? Because when we differentiate secant x, all right, we will get secant x tangent x. Okay, so this secant x tangent x is the differentiation of secant x. So when we integrate, this will actually reverse back to the secant. All right, so this one is actually the du. Now, after we break this into tangent 2x, 2k x, right? Tangent to the power of 2k x multiply tangent x. So furthermore, we change this one, tangent square x, to secant square x minus 1. Okay, change this one to secant square x minus 1 using the same identity as well. Okay, and we actually integrate from here. Okay, now the guideline number 3, if we integrate tangent x only, all right, no second factor here. Okay, and this is what we do. All right, first, if this n, all right, is even and positive, all right, so this is what we do. So first, right, we break this into tangent to the power of n minus 2 x times tangent square x. Okay, now so we can actually use this tangent square x and convert to secant x using the identity. Okay, so from here we have the tangent x, right? So then we can actually integrate. Now when we have, all right, only with secant to the power of m x dx, so where the m is odd and positive, then we are going to use the integration by parts, right? This one we learned actually before. So now when none of the first 4 guidelines applies, then we are going to convert all this to sine and cosine. Okay, so let's take a look on an example here. Now we want to integrate tangent to the power of 3x over square root of square root of secant x. Okay, now because we expect to use the power rule, right, for u equals to secant x, then we need to save a factor, right, secant x tangent x for du, all right, and convert the remaining tangent factors to secant. Okay, so first we change this to the power. So we have secant x to the power of negative. Okay, square root, what is the power? Negative 1 over 2. All right, and the tangent to the power of 3x. So after that, okay, we are going to break this, okay, to 1 tangent x. Okay, so we have tangent square x and break this into, all right, tangent square x times tangent x. Now after that, all right, because we intended to use the secant x to be the u, so we can actually, all right, create another secant x here, okay, by dividing another secant x here. So, right, in this case, we divide another secant x, and here we have another secant x, and from here, right, we get negative 3 over 2 secant x. Okay, now after that, right, so we are going to change this to secant x using the identity 1 plus tangent square x equals to secant square x. So change this to secant square x minus 1. And this one, we are going to save for the du. Okay, now, by having this, now we can expand, all right, secant x to the power of negative 3 over 2 multiply secant square x, and after that multiply 1. Okay, so now by taking the secant x to be the u, now we have the secant x u, differentiate u dx, du dx, we have secant x tangent x, and the du will be the secant x tangent x multiplied dx. Now, so this one is actually the du. Okay, now replace all this into the integrals. So we have integration. So this is u to the power half minus this one is u to the power of negative 3 over 2. And this is actually du. So we can actually integrate from here. Now, so integrate u to the power of half, we have 1 over 2 plus 1 and divided by 3 over 2. Okay, so 1 over 2 plus 1 is 3 over 2, so divided by 3 over 2 minus, and this is negative 3 over 2 plus 1, so we get negative 1 over 2 here, so we have negative 1 over 2 plus c. So at the end, we will have 2 over 3, and this one is u to the power of 3 over 2, negative, negative become positive. So 2, okay, 1 over 2 now become 2, okay, u negative 1 over 2 plus c. Okay, change the u back to second x. Now we have 2 over 3 second x to the power of 3 over 2, like this. Plus, change this back to second x. We have 2 second x to the power of negative 1 over 2 plus c. All right, so from here, we actually solve the integration. So, right, under this chapter, we learn how to actually solve the integration of involving power of sine and the power of cos, and also the integration involving the power of secant and the power of tangent.